Welcome back to the Algebra Solver channel, the home for the weakest student in your mathematics class. For today's problem, we have a quadratic equation, 18x squared plus 9x plus 1 equals 0. We are going to solve for x using specifically the quadratic formula. Remember that we can solve this using other methods, but for this particular problem we need to use the quadratic formula. And before we proceed with solving this problem, I would like to show you a special video on how to approach, how to attack problems involving the quadratic formula. Please wait for it. Thank you. Hi, I'm Thad's the Solver. If you are the weakest student in your maths class, you've come to the right place. Don't worry. I'm here to help you. In the course of creating videos involving the quadratic formula, I realized I needed to summarize the attack strategy in solving the quadratic equation because I had to repeat myself in every problem. So I created this video on the notes and tips and the common possible sources of mistakes whenever we use the quadratic formula. I will insert this video into its problem we solved. If you have seen this section already, you can skip this video to the portion where we start solving the problem given. Let us proceed with these notes and tips in solving quadratic equations, specifically using only the quadratic formula. The quadratic formula seen here is applicable to all quadratic equations there. And those equations must be, of course, algebraic polynomial equations, because the quadratic formula cannot be applied to other types of equations, such as the transcendental equations, those involving trigonometric functions, exponential functions. In this case, we focus on the polynomial ax squared plus bx plus c equals 0. That's the standard form. And we have the quadratic formula. This quadratic formula will give us values of x, and this quadratic formula is general. In fact, we don't need to know all the other techniques of solving a quadratic equation, although we still have to learn those techniques, because in math, the more techniques you learn, the better. And there are also cases where that technique that we learn can be applied in other branches of math and science. Now, here is the quadratic formula. That's negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, now have you memorized this formula yet? Now this is like the Pythagorean theorem. This is very basic in algebra, and let me share with you a tip, a technique in how to memorize this. When I was young, I would memorize this on a short-term basis, put it in my head, and then I would write this down on a piece of paper 50 times in succession. 50 times on a piece of paper, a large piece of paper, of course. I write the formula down from my short-term memory, and then the next day you'll be surprised. After writing it for 50 times, you would still remember the quadratic formula. That's what I do also for important formulas where I keep on forgetting them. Sometimes, there are formulas you just simply can't memorize them. So what I do is I write them down 50 times. Alright, so let's proceed with some tips and techniques. To solve for x using the quadratic formula, this is our attack strategy, this is our solutions strategy. I'm going to highlight it. You must use, I've shared with you here on the left side of the page, our objective, our attack strategy. Our objective is first to manipulate the given problem, the given equation, so that it will be of the standard quadratic form ax squared plus bx plus c equals 0. A is the coefficient of the term x squared. B is the coefficient of the term x, and c is the constant. You must manipulate the equation so that it will be of the standard quadratic form ax squared plus bx plus c equals 0. And then once you have achieved the standard quadratic form, you apply the quadratic formula. It's that simple. You can actually solve this in 5 minutes, because all you need to do is to plug in these coefficients into the quadratic formula. So I will share with you here also on the left the tips and the techniques that you should be aware of when solving quadratic equations using the quadratic formula. Again, there are many ways of solving the quadratic equation, but in this particular case, we have to use the quadratic formula. That is the nature of the problems we're given. First, let us go over the quadratic formula first, so that you will be familiar with its form. Here's the quadratic formula. X equals negative b plus minus the square root of the quantity b squared minus 4ac all over 2a. When we solve quadratic equations using the quadratic formula, you must realize that there are exactly two roots or two solutions or two values of x that will make the quadratic equation correct. There are two. Exactly two. Not 3, not 4, not 1, but exactly 2. This is due to the fundamental theorem of algebra, where if you have an algebraic polynomial equation of degree n, in this case the n equals 2, then you'll have exactly n roots. In the case of the quadratic equation, algebraic quadratic equation, you'll have exactly 2 roots, because the degree of this equation is 2. So you will have exactly 2 roots. And in the quadratic formula, this is shown by the plus and the minus sign here. That means the first solution, the first x solution, the first root will be when we evaluate this formula using first the plus sign, and it will give you one of the roots, one of the two roots, one of the two solutions. Now, if we perform the minus sign, the subtraction sign here, then that will give us the second root. So there will be two roots. We're not going to add and subtract simultaneously. It has to be done successively. There's no such thing as add and subtract simultaneously here in this formula. So we'll have exactly two roots. Right, so let's proceed. Now, look at the term here, negative b. Be careful because it's a negative b. So if b happens to be negative, then that will be negative of a negative, which becomes a positive. So be careful about the negative there. Now, another thing that we should note is the expression under the square roots, and that expression is b squared minus 4ac here. B squared minus 4ac is an expression that is called the discriminant. It's very important because the value of this entire expression, should be positive. Should be positive because if it is negative, the value of this, if it's negative, then you will have the square root of a negative number, which is, involved in advanced algebra, because that will lead into the concept of imaginary numbers or complex numbers. So at this stage of your studies, if your discriminant, the quantity b squared minus 4ac is negative, then try to check your multiplications there and your subtraction, because most likely you committed a mistake there in the calculation of b squared minus 4ac. So to summarize, the moment you have a negative quantity for b squared minus 4ac, which is called the discriminant, which is the expression inside the square root, then if it's negative, then you probably made a mistake at this stage of your study of algebra. Well, it happens that there will be a square root of a negative number, but that is far advanced. So that's your hint that you made a mistake there if you get a square root of a negative number. Okay, once you have the standard quadratic form, then by the process of identification, you will know the value for a, and you will substitute it into the formula, and then you will know the value of b, you substitute it into the formula, and remember there's a square here, there's an exponent, and then you substitute the value of c into the formula here in the discriminant. So that's by the process of specific identification. And let's go to the tips here on the left. Now on the left are tips. Number one, there are exactly two roots, but it could be repeated though. We call that multiplicity. It could be the first and the second roots would be the same value. Let's say, for example, 4 and 4. The first root is 4, the second root is 4. It's possible. But there are two roots. Number two, for the tips, watch out for the positive and negative signs. Especially here, for example, in the negative b. Example for here in the discriminant, that's a minus there. That's a subtraction. And then sometimes your a and your c, or your c could be negative. So you will be multiplying here positive and negative numbers, or negative and positive numbers, or negative and negative numbers. So watch out for the positive negative signs. That's number 2. Number 3, use as many parentheses as possible when substituting values into A, B, and C. For example, if A equals 2, B equals 3, C equals negative 5, make sure you use parentheses when you substitute the values. What is the purpose of that? The purpose of that is to avoid any confusion. Parentheses, parentheses, you put a parenthesis here, parenthesis there, parenthesis there. Okay, try to make sure that you have a parenthesis here, parenthesis here, parenthesis here, parenthesis here, parenthesis here, so that you will not be confused. That's tip number 3. Now tip number 4. Tip number 4, the value of the discriminant, which is the b squared minus 4ac, ought to be positive. Otherwise, it would result into a square root of a negative number, which is far advanced. So for our intents and purposes here, we should get a positive number. Tip number 5, don't forget the exponents, especially here in the discriminant. You have b squared and there's exponent there too. We all make mistakes with that exponent. We forget, especially if b, for example, is a fraction, like let's say 3/2, and you take the square. Make sure that you properly evaluate the exponents for both the numerator and the denominator. Sometimes you just remember to square the numerator but not the denominator. Okay, so don't forget about that. And the 6th tip that we have is that subtracting a negative number is equivalent to adding a positive number. For example, this is very important because this happens many times when we try to manipulate the equation so that it will be of the standard quadratic form. We'll be doing a lot of this. Subtracting a negative number, let's say 8, that is the same as adding a positive number. Subtracting a negative number is the same as adding a positive number. Or subtracting a positive number is equal to adding a negative number. So negative of negative is positive, or negative of positive, or positive of negative. No, they are equivalent, they are equal. So don't forget this, because we will be using this technique. Okay, we'll be using that technique almost in every problem. Alright, so those are the basic tips that I could share with you. And again, I'm going to insert this video into each problem that we solve involving the quadratic formula. Now let's proceed to solving the given problem. Now that you have learned how to solve the quadratic equation using the quadratic formula, and all the tips and the notes that was found inside this video, let's proceed and solve this problem. Alright, so is this already of the form ax squared plus bx plus c equals to 0? Is it already of this form? The answer is yes. And specifically now we can identify the values for a, b, and c. Now, by specific identification, a equals 18, b equals 9, and c equals 1. Look at that. So here, that's 18, that's a, and then that's b, positive 9, and that's c, positive 1. Now, we are ready to use the quadratic formula directly without need of any simplification. So by direct substitution into the quadratic formula, we would have x equals negative of b, which is 9, plus minus the square root of b squared, that is 9 squared, remember the parenthesis, minus 4 times a, which is 18, times c equals 1, all over 2 times 18. Now it's good to note that there are no negative signs here, so you just need to multiply them directly. And remember the square here, and also there's a subtraction there. So let's simplify this entire thing. It's just a matter of arithmetic now. Okay, let's proceed. So this is x equals minus 9 plus minus the square root of 9 squared is 81 minus 4 times 18 times 1 minus 72 all over 36. Let us simplify further. X equals minus 9 plus minus the square root of all over 36. That's the square root of 9. So we're going to simplify further. So this is x equals minus 9 plus minus square root of 9 is 3 all over 36. So finally, this is the solution now. We'll have two solutions there. When we execute the addition here, that's x1, our first root, and when we execute the subtraction there, you'll have x2, which is our second root. Okay, let's try to simplify now. By the way, remember that we had a positive 9 here in the discriminant, so there's no square root of a negative number. So that's one way of determining whether you did the multiplications inside the square root properly, because if it comes out as a negative, that would be an advanced topic which is not suitable at this stage, so we should have a positive there. Okay, let us simplify the expression. So this is minus 9 plus minus 3 over 36. So let's execute the addition part. X equals minus 9 plus 3 over 36 all over 36. So let's factor this. X equals minus 9 plus 3, that is minus 6 over 36, that is minus 1 over 6. So x1, the first root, is minus 1 over 6, and that is our first solution there. That's our first zero, that's our first root, that's our first solution. Okay, now remember we have executed the 9 minus 9 plus 3. This is the first roots, right? So that's x1. Next we will solve for x2, the subtraction portion. Okay, so next we will look for x2. In this case, this will be x2 is minus 9 minus 3 over 36. That's equal to negative 12 over 36. Factoring that, x2 will be equal to, divided by that's negative 1 over 3. Is that correct? 12 times 3, 36. So this is our second root by executing the subtraction portion from our original solution. Okay, so the solution we have is that x1 equals minus 1 over 6 and x2 equals minus 1 over 3. Is that correct? Now we expected 2 roots, so now we have 2 roots. The first root is minus 1 over 6. The second root is minus 1 over 3. So of course what we need to do is to have a cross-checking operation. Let's do some check. Okay, we have cleared our board and let's try to do the check. This is the cross-checking operation for the first root, which is x1 equals negative 1 over 6. Again, remember there are exactly 2 roots as predicted. So x1 equals negative 1 over 6. So let's substitute into the original equation. So that is 18 times negative 1 over 6 squared. Remember the parenthesis there. Plus 9 times negative 9x is negative times negative 1 over 6 plus 1 is that equal to 0. Let's simplify. So this is 18 times negative 1 squared is a positive 1. That's an even exponent. So that's 1. And don't forget the denominator. You have to square it. So 6 squared is 36. Now this positive plus this is now negative 9 over 6. Negative 9 over 6 plus 1 is that equal to 0. Remember here that we're trying to have a common denominator. So the common denominator would be 6. So we're not trying to simplify this 6 anymore. Okay. So we should maybe reduce this to 6. That's our strategy there. So let's proceed. Okay. So this will be 18 over 36 minus, again that is plus minus. Remember our tips, remember our tips video. So this is now minus 9 over 6 plus 1 is that equal to 0. We're doing this step by step, right? So factor this out. This is 6 times 3, that's 18. Factoring out 18, factoring out the 36. This is 6 times 6. What's the purpose of factoring it? So that we'll have a denominator of 6, which is the same as the denominator here in the second term. So this is 9 over 6 plus 1. Is that equal to 0? Okay, let's move up. So 6 over 6 is 1. 6 divided by 6 is 1. So what we will have will be 3, sorry, that's 3 over 6 minus 9 over 6 plus 1. Is that equal to 0? Very simple, right? But we're doing this step by step for the weakest student in math. So 3 minus 9, so that is minus 6 all over 6 plus 1. Is that equal to 0? Okay, we should do it step by step. So this is negative 1 plus 1. Is that equal to 0? 0 equals 0. Check. Okay, there's a check there. We have now proved by checking, by substituting the first root, the first solution into the original equation. So we have proved now that really x equals negative 1 over 6 is a solution, is a root to the equation 18x squared plus 9x plus 1 equals 0. That is a quadratic equation. Now let's proceed with the next check. Okay, let's proceed with checking for the solution x2 equals negative 1/3. Let's do that check now. So this is 18 times negative 1/3 squared plus 9 times negative 1/3 plus 1. Is that equal to 0? Now remember here the parenthesis, and remember there's a square, there's a parenthesis there, and the x now we're using is this 1/3. Okay, let's move the board up. So let's simplify. That's 18 negative 1 squared, that is positive, that's a square, that's an even number. So that's 1 over 3 squared is 9. Remember the denominator has to be raised to exponent 2 also. Plus negative, that's negative 9 over 3 plus 1. Is that equal to 0? So you simplify 18 over 9, that's 2. Minus negative 9 over 3 is 3 plus 1. Is that equal to 0? So simplifying, this is now 2 minus 3 plus 1, 0 equals 0. Correct. So therefore we have proved that x2 or x equals negative 1/3 is also, and it's the second of the two solutions, or the two zeros, or the two roots of the equation. The equation 18x squared, the 18x squared plus 9x plus 1 equals 0. We have derived, we have arrived at the solution, and we have done a cross-checking of our answers. So now we are more confident that you have arrived at the correct solution. By the way, in real classroom examinations, there is no need for you to check. So we're just using this one so that you'll be able to gain confidence, and for you to gain that special, extra, additional skill of being able to check whether you have the right answer or not. Thank you. And I hope the weakest student in class has learned something, and we hope that from zero you will become a hero. From zero to hero. Thank you, and see you in our next problem.